All right, boys and girls, this is solving trigonometric equations. This is the lesson that we do after looking at trig ratios for angles larger than 90 degrees. So by now you should be familiar with your trig ratios, the special triangles, and things like, primary arm, terminal arm, the primary angle, and the related angle, which we draw from the terminal arm with a vertical line straight to the x-axis to create the related angle and triangle, for which we use the sine theta, cos theta, and tan theta ratios. You should also know the unit circle and coterminal arms, right? Or coterminal angles. So the cast rule, all that stuff is, things that we've covered. And, really hope that you have a decent grasp of that. But, we'll reveal some of it when we talk about this stuff. It gets repeated, and hopefully that'll help you solidify your understanding on solving trig equations. Here we go. And if you want to know in terms of a point of reference where I'm getting this, I do want to give credit to Jensen Math. This is a free site where another teacher has posted his lesson plans and the solutions and worksheets and so forth. And I find them to be quite logical in order, and they're just great resources for teachers to teach lessons from. So, access it and see if there's any additional help you can gain from that too. It says here in this section, let me see if my mouse is working. I think we're good. Okay. It says here, in this section, you will learn how to identify different angles that have the same trigonometric ratio, as well as learn how they are related. Okay. Different angles that have the same trig ratios. Interesting. To do this, you'll have to visualize a terminal arm rotating around a circle centered at the origin of a grid with a radius of r. This is done so that we can extend our understanding of trig functions for a broader class of angles and see how different angles are related. And again, boys and girls, you can click on this. This is the unit circle that you can access, and you're going to be able to have an interactive circle that you can spin around and see those trig ratios in action. So some helpful reminders. Before I did that little jump there, let's see if I can reset this. There we go. For any point P, x, y, right, in the Cartesian plane, the trig ratios for angles in standard position can be expressed in terms of x, y, and r. R, as we discussed in the previous lesson, is the hypotenuse, right? And it's always going to be positive. So if I give you a point, you can mark off the point. And of course, you'll have a primary angle. And if you're in quadrant 2, 3, 4, then you'll have a related angle instead with the letter B. You just build the triangle there, and you build it against the x-axis, not the y-axis. And you look at the triangle and you figure out the sine, cos, and tan. Always thinking about the cast rule here. This is the cosine, the adjacent, and the tangent. Summary here to say that only cosine ratios will be positive in this section. All of the ratios, sine, cos, and tan, will be positive here. Sine will be positive only here. That means everything else will be negative here. And tan will only be positive here. Okay? We'll work some examples in the previous lesson to kind of demonstrate that as well. Okay. So let's talk about this part over here. It says for any point x, y in the Cartesian plane that intersects the unit circle, the trig ratios for angles can be expressed in the in the terms x, y, and r, just like we did before. However, the r can be substituted with the number 1 now, because we're saying this is a unit circle, so the radius is actually 1. And boys and girls, you can see that here, right? And you got x, you got y, and you also have r, which is 1. So from there, look inside the triangle and build your trig ratios, right? Tan is opposite over adjacent, that's y over x. Sine is opposite over hypotenuse, that's just y, really. And cos would be the x value. All right, let's keep it going. Okay, a little bit of a note here. Let me see if I can explain it. It says, we know the x-coordinate of where the terminal arm intersects the unit circle is equivalent to the cosine ratio, and the y-coordinate is equivalent to the sine ratio. Because, like we said, we said here, sine theta is equal to y, right? So then, the y value is actually equal to sine theta, right? You can say it in reverse. If cos theta is equal to x, then x is equal to cos theta. So, using that as an understanding, you can notice the diagram on the right here. I did some labeling, but notice that both the 45 and the 135 degree have the same reference angle, right? Because, let me fold this down for a second. Good color. Let's use black. Because, the primary angle in the first one, this here is 45 degrees, right? We want a 45 degrees, but in the second triangle, the primary angle is your 135 degrees right there. There's your 45, there's your 135. So with the 135, you can see that my primary angle, I've traveled 135 degrees. You could say then theta is equal to 135. But your related angle, which only occurs in the second, third, and fourth quadrants, is marked by this symbol here, is 45 degrees, okay? And you would build the triangle from here. And, this is 45 degrees. And so you have a special triangle, the 45, 45, and 90 triangle. And then, of course, you would label out the sides, right? I got this here is a full -1, and that's 1 right there, and that's √2, right? It's a special triangle. And so if you had to figure out all these different values, we know that sine is opposite over hypotenuse, which is 1 over √2, which we would have to write as there we go, √2 over 2 right there, right? And then cos theta, which is the x value, is adjacent over hypotenuse, which is -1 over √2, which we also have to convert like that, right? We have to rationalize those denominators. So you end up with your sine and cos. Cool. Let me get back to the note. Notice that both the 45 and the 135 have the same reference angles. Since the angles fall in quadrants, well, this is in quadrant 1, right? This is in 1, and this is in 2, and this is in 3, and this is in 4, right? Since they're in quadrants 1 and 2, respectively, they will have the exact same y-coordinate, but the x-coordinates will have the same absolute value, but will have opposite signs. So there's a calculation for sine 135, right? Instead of saying sine 135, this is actually, they'll give you the question as sine of the principal angle, right, theta, which you will now need to convert to sine of the reference angle, right, which is a 45, in our case over there. Right? And also keep in mind, this is CAS. This is the S area in the third quadrant. So we know that that's always going to be positive in the third quadrant. And that's why I didn't change the sign in front of the word sign. And I just left it as positive. So that's sine of 45. And then you just put in your calculation. We know it's going to be positive anyways. So we go, that's 1 over √2. And we got to rationalize the denominator and write it as √2 over 2 like this. The important takeaway from this is that there are two angles between 0 and 360 that have the exact same sine ratio of √2 over 2. You can see that, right? The sine ratio is √2 over 2 here. Let's see if this highlighter works. Right there, that's √2 over 2, right? And it's also √2 over 2 here. Remember, the y value is the sine ratio. Good, let's exit the drawing. Good. It just takes it away too. That's not that helpful. All right. Let's look at one example over here. It says solve the following equations for theta is in between 0 and 360, including 0 and 360, and then round your answers to the nearest tenth of a degree. So we're going to look at this one. It says sine theta is equal to negative 0.7. So we're like sine theta is equal to negative 0.7. How do we actually do this calculation, right? Well, if you calculate what theta is, you would have to do the sine inverse. And you could say, theta is equal to sine inverse of negative 0.7. And that's exactly what's going on right here. Just calculating the angle. It turns out that the angle is 315.6 degrees. And we found that but just by drawing it in over here, it's about 315.6 degrees. How did I know that? It's just eyeballing, right? I know that it's 270 right here. So it's in the fourth quadrant, and I'm labeling it 315.6, right? And then I did a little bit of calculation, just go, okay, well, if I connect it straight to, right, to the x-axis, I'm going to have here a related angle that's 44.6. And I did that just by finding like 360, and we subtract the 44, we subtract the 315, and I get 44.4, and that's that. Okay, so now that we have this, we're like theta, right? We have to solve for the angles in between 0 and 360 for theta, not the related angle, and round your answers to the nearest tenth of a degree. So, the first one is 315.6. Well, what's the other one? Well, the other one, think about where sine is negative. Right? And we know that the related acute angle is 44.4. So sine is negative. If we work out, work it out, C-A-S-T. Sine is negative here, and it's also negative here. Here it's positive, so we don't want this, and here it's positive, we don't want this. We want a negative sine value. So we can see we already got the one in the fourth quadrant, but the one where the tan is, that third quadrant is where we're going to have to draw the other one, right? And so what we do is we create the same related acute angle inside, which is the 44.4, and we calculate that measure from the 180 to the 44.4. This much. And you go 180 plus 44.4 is 224.4 degrees. So you could see that these are the two angle measures, okay, that will give us 315.6 and 224.4 are the two angle measures that'll give us a negative sine value of 0.7, or sine theta is negative 0.7. Okay, so same general idea for the tan situation over here. First, we got to figure out what actually theta is, and it turns out to be 64.5, and that'll give us one of the angles. In this case, 64.5 is right here. You see I labeled it right there, right? And that's theta. And it's 64.5 degrees, understood. That's the first one. But if you think about CAST, right, we're thinking about tan is actually positive. So it's positive here in the first quadrant, but it's also positive here in the third quadrant, okay? In the second quadrant where the S is, only sine's positive there, and tan would be negative. And in the fourth quadrant, sorry, only cosine is positive, and everything else is negative there. So we're looking to get tan as positive. So tan is positive in the first quadrant and the third quadrant. So all I have to do is enter the 64.5 degrees as a relative angle based off of the x-axis, and that'll send us to this triangle right here. There's a 64.5 degrees, and if I measure it, that's 180 degrees right here. We're going to add the 64.5, and we end up with 244.5. Okay. All right. What about example 2 here? Example 2. The point, negative 719, lies on the terminal arm. Find the angle to the terminal arm, principal angle, comma, theta. That's another name for it, right? And find the related acute angle, which we know is the reference angle, okay? With the B shape right there, the beta symbol. So, okay, let's do this. If we plug in the negative 7 and 19 and we graph it, that's actually going to end up in the second quadrant because there's a negative 7 on the x axis and then 19 on the y. So I end up putting in a little dot here called negative 7, 19. Label in the sides, you got negative 7 on the x and 19 on the y. Makes sense so far. Do I know the r value, this radius length? It's not a unit circle, right? Obviously. No, I don't. Do I need to calculate it? I could, but only if I run into a situation that requires me to produce or use the r value, which actually for the tan, it is y over x, so I don't need the r value. I'm not going to calculate it. It's just unnecessary. So looking at the quadrants over here, I could tell you that CAST indicates that in the third quadrant, only the sign ratio will be positive. I here am dealing with a negative 7 over 19, and I have to talk about the tan ratio. Do I? Because I have opposite and over adjacent. So I'm just going to plug in opposite over adjacent. I can figure out the r, but I don't need it because, if I just use opposite and adjacent, I can actually figure out what the related acute angle is. And you can see I've substituted in tan theta, or tan b is equal to negative 7 over 19. And so beta is equal to tan inverse of 19 over negative 7. And then you plug that through and you get 69.8 degrees. This is 69.8 degrees. So if that's 69.8, then theta is equal to, well, this would be the full 180 degrees, and we'll take off the 69.8, right? So it's 180 degrees, subtract 69.8, that's 110.2 degrees, rounded to the nearest hundredth. And so if I add up these two, the 110.2 and the 69.8, I should get 180, and I do. That's example 2. We'll do 1 or 2 more examples. Let's talk about example 3. For the point P 511, it lies on the terminal arm of angle theta in standard position. So, all right, draw a sketch of angle theta, determine the exact value of r, determine the primary trig ratios for theta, then calculate theta to the nearest tenth of a degree. Okay, so you can see I've gone ahead and plotted in 511 right here, labeled it as 511, and I've got the 5 there, I've got the 11, and the theta is right here, of course, but I don't have r, so I got to calculate r, and you can see that this is what this step is, right? R is the hypotenuse, so we'll go with the Pythagorean Theorem. R squared is equal to a squared plus b squared, and 5 squared plus 11 squared, and 146 square root. That's going to be, I don't think it's going to be a clean number, to be honest. 146, let me drop this a little bit, and we'll hit the square root, and we get 12.08. Look, I have no desire to write that out. That's probably going to be a repeating decimal as well. It goes on, maybe. Yeah, it'll probably go on as well. So I don't really have a lot of desire to write out all these numbers. So I'm just going to use root 146. That's an exact answer right there for my r value. Okay, so now that I got 3 sides, I've got to figure out from that theta what the sine, cos, and the tangent ratios are, and they are as such: opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, listed as such. And then the last thing is determine the arch. Okay, then calculate theta for the nearest tenth of the degree. So, out of these 3 trig ratios, I am going to use the tangent ratio because the tangent ratio here uses solid numbers like 11 and 5. I don't want to bring in that 146 and try to do tan off of that off of my calculator. I bet it's going to round numbers and stuff like that. It won't be the most accurate answer I can get, but the 11 over 5 will do it for me. So I do tan inverse of 11 over 5, and I get 65.6 degrees. Let me just show you right quick. So we're going to go on this calculator. You have to do it first. 11 divided by 5. I got 2.2, and I have to go tan inverse on it right there. I got 65.55 or 65.6, right? It's the nearest tenth of a degree. Last one. Yeah, it says solve the following for theta. For the solve the following equation for 0 is less than or equal to theta is less than or equal to 360, meaning theta is in between 0 and 360, yeah, including 0 and 360. So, all right, as 3 cos theta plus 1. We don't really know how to work with that, but we can try to solve for theta by moving things around, right? So I'm going to send this 1 over, and then I'm going to divide everything by 3, and that should look like this. This way I get myself into a very comfortable position that I'm used to. Cos theta is equal to negative 1 over 3. And I can tell you right now that because cos theta is going to be negative, C, A, S, and T, I don't want to be here, and I don't want to be here, because cos theta is going to be positive over here, right? It's positive here. So you're actually going to end up here. So I've gone ahead and drawn a couple of terminal arms in those spots. One in the third quadrant, one in the fourth quadrant. And in these quadrants, cos will be negative, okay? And all right, so now we just do the cos inverse of theta, and we're going to get cos inverse of negative 1 over 3, and we're going to get theta is equal to about 109.5 degrees, okay? And I'm going to write it in. That's theta, 109.5 degrees. But if theta is 109.5 degrees, then what is the related angle? Right, the related angle is 180, subtract that 109.5. So if I do that, the related angle of beta is equal to 180 subtract 109.5. That gives me 70.5 degrees. So I know that's 70.5 degrees. And that's for the one in the second quadrant, right? 109.5 degrees will put you into there, which is 70.5 degrees. Good. And I can also throw that 70.5 degrees on this side too, because I know I'm also going to be in the third quadrant. And if I do that, that'll pump it all the way to 180 plus 70.5, which would be 250.5 degrees. That's my other angle. Full all the way around. This is 250.5 degrees. So I have two angles here. I got theta 1 and theta 2, because there's two angles that'll give you that same equation, where cos theta ends up being negative 1/3. Okay, so there's looking at two possible angles. Anyways, that's example 4, and I encourage you guys to try the worksheets and try the practice from our textbook on these things as well. Boys and girls, as I am not present in class and you are working through these questions, you'll understand maybe the supply teacher may not be able to help you with these questions, so please speak to your neighbors. Some of the other students are getting a decent grasp of it, or are able to get these answers because they're checking the answers on the bottom of the worksheet, or the answer key that I post, or the textbook, right? So go over their solution, see if it makes sense. And if you still would rather talk to somebody specific, you can take a picture of your work and email it to me, and I'll try my best to get back to you. Or you can just go to the math office during your lunch and talk to one of the other math teachers, and they can work through a question or two with you as well. A lot of them teach grade 11 university, so they'll be more than happy to help you, okay? Just make sure you try the question first. That's what they want to see. Other than that, boys and girls, have yourselves a great day, and take good care of yourselves. I'll see you guys as soon as I can get back. All right? Bye.